Okay, chapter 6, we are going to move into vectors, parametric equations, polar equations, but we're going to start in section 1 with vectors. And many of you have seen these in physics or in somewhere else. I think we even talk about them in geometry a little bit, so let's just review. A vector is different from a scalar type. Something like length is a scalar. It's just a single number. Even area, those are scalar types because they just represent one thing, okay? Volume is a scalar type, but a vector is something that has both magnitude and direction, okay? And so I could have something, if I threw this marker up and to the right, that would be a vector because I'm showing a direction and a magnitude. So if I put this in a coordinate plane and maybe had the initial point start at something like 2, 3, and I go up to 4, 9. Okay, so that's where my terminal point is. So that's terminal, that's where it ends. And here's initial. Terminal, that is spelled right, terminal point, initial point. I can come up with what the vector is that goes between those points. And so the first thing we're going to talk about is component form. And component form is going to look like this with these brackets. And basically you always say where I'm going minus where I started. So 4 minus 2 would be that coordinate. 9 minus 3, so that's the amount left or right that I'm going. 9 minus 3 is 6. Okay, so that's the vector. Now, this vector, if there was another vector that maybe started at negative, let's say it started at 2, negative 5. And it went to 0, 1. If I did 0 minus, sorry, I should have had that to be 4. I want to try to, if I did 4 minus 2, I'd get 2, and if I did 1 minus negative 5, I'd get 6. These two vectors would be considered equal. I like the geometry term of congruent better, but it's just showing that they're going in the same direction. They are not the same, but they're equal in their magnitude and their direction. Okay? All right, what is their magnitude? Magnitude is going to be the same thing then as what the length is. So I'm going to erase this second one. And the easiest way to find magnitude is to basically just do a right triangle. And so I've already said the change here is 2, the change there is 6, and I can just do Pythagorean theorem now. So 2 squared plus 6 squared, and take the square root. So 4 plus 36 is 40. So I would say the magnitude of this vector is equal to 2 root 10. I could have a decimal. A lot of times they'll give a name to a vector, call it v, and the way they'll write magnitude is it's like absolute value bars. Okay, that is the magnitude of this vector v. Okay, if I'm adding vectors, I have something that's going up and to the right, so we say that vector is 2, 6. And then I have a separate vector that is going up and to the left. Let's say that one's negative 2, 4. I can add those vectors. So it'd be like if I put 1 onto the end of the other, and then combined, they would end up being, so I'd say negative 2 plus 2, and 4 plus 6. I would get something that's 0 and 10. So adding vectors is very easy. So that gives the component form of the resultant vector is the term that we often use.